Yes, the question says a rugby post of 6.0 meter long lies flat on the ground. When the narrow end only is lifted on the ground, the force needed is 140 Newton. When the thick end only is lifted, the force needed is 280 Newton. Deduce the weight of the posts and the distance of the center of gravity from the thick ends. Now, before start solving the question, we need to elaborate a little bit further the question so that when we start solving, it will be very easy for us. Now, from the question, we can find out that the problem explored the application of the principle of moment to determine the weight and center of gravity of rugby post. The post lies flat on the ground and is lifted alternately from each end, requiring the different forces due to its non-uniform shapes. Why it's non-uniform? Because the diameter of the post is not constant throughout its length. Now, by analyzing the forces needed to lift each end and applying the concept of rotation, we can deduce both the total weight of the post and the location of its center of gravity relative to the thick ends. Now, after understanding this, now we can start solving the question. Now, let us do it.
Yes, now we need to draw the diagram, but keeping in mind that the rugby post, according to the questions, doesn't have a constant diameter through its legs. So I'm going to draw the first diagram, which will represent the lifting force, which is applied at the left-hand side of the narrow post, which is the narrow part. But again, we will have a mass, and then we apply the principle of moment, and then we'll form the equations. Yes. Again, we need to draw the diagram to represent the scenario. So I'm going to draw the first diagram first. So this is our null. This is our rugby post of this length. And here on the left hand side, which on the narrow part, we have applied, there is an application of force of 140, lifting force of course, 140 newtons. But again, we have the mass, and the mass, the mass of the rugby post, M. Now, M, which is at distance x from the from the thicker ends. Then, of course, I'm going to assign names at the end of these posts, at both ends of this post. The thicker ends will be A, and then here will be B. Then the distance of C, which is the center of gravity of this from the narrow part, is 60 minus this one meter. Now, we apply the principle of moment, which says the sum of clockwise moment is equal to the sum of anti-clockwise moment. Now, we're going to take moment from one of these ends. What end should we take? This one. Then we are going to take taking moment about A. Taking moment about A. Now, the sum of clockwise moment, clockwise equal to the sum of and clockwise. So then we have to decide between M and F which one of these will cause clockwise direction of the body or anti-clockwise direction of the body. Now, since M up downward, we expect this to cause clockwise direction, and this one, since is a lifting force, will cause anti-clockwise direction. So M times X equal to 140 times the range of this, which is 60. Mind, we have just said that our reference point is A. So therefore, all our distances would be referred to this point. That's why here A, B is 60. That's why since 140 is located at the narrow part of the load of the lug, therefore it will be 140 times 60. This one will be equation number 1. Of course, I'm going to draw another diagram to which will show what's going to happen when applied force is um, at uh, A, which is the thicker part. So therefore, F here is 180 newtons. So now mass is still located at the same point. Therefore, this is M, and this is the center of gravity, and the distance of M, the distance of A to B is still the same because they still the same post, which is this one, but the distance of the M from thicker end is still X. So again here the distance would be the same, 6.0 minus X meter. Now again taking moment about one of these n. Which one should we take? We have to take B because at A there is an application force. So we're going to take moment this time at B. So now the sum of clockwise moment equal to the sum of and clockwise. So now we have to decide, and between this one F and M, which one will cause the body to rotate clockwise and which one will cause the body to rotate anti-clockwise. Now since M is acting downward, we expect this to cause the body to rotate in this direction, which is anti-clockwise, while this one will cause the body to rotate clockwise. So what we are going to have, M times 60 minus X equal to this one, F which is acting at a distance 6 meters from B. So therefore 280 times 60, and this one will be equation 2. So now I'm going to write here, take equation 2 divide by equation 1. So what I'm going to have is M 6 minus X equal to this one times 6 divide by equation mx over 140 times 6. Then 6 and 6 will cancel each other, then m and m will cancel each other. So here we're going to remain with x, 6 minus x over x, and then here 1, 2, so therefore here we're going to have 2 over 1. Now if we cross multiplication here, we're going to have this one, and then 2x. So what we have, 3x, 6, divided by this, divided by 3 both sides, we are going to have 2 meters. So x is 2 meters. Now what does x represent? In our case, x is the distance of center of gravity from the thicker end. So x the distance of center of gravity from thick end is 2 meters. So this is how we can obtain the distance of center of gravity of the rugby post from the thick end. But we still have some unfinished business here because the question demands us to find even the weight of the post. How are we going to do it? It's kind of simple, since now we have the value of x. Now I have to write here from equation 1, which is mx 140 times 60. From this equation now, we can obtain the value of m, which is the weight of the lagging post. But you can decide whatever you like. Maybe you can use equation 2 or equation 1. For me, I've decided to use equation 1, but it's okay too if you're going to use equation 2. So I have to lie here. If I have to lie here, x equal to 2 centimeter. We have obtained this from our previous calculation. So I'm going to substitute here instead of having x here. I'm going to substitute 2 here. So we are going to have 2m. Then 140 times 6 divided by this, Well, we're going to have m equal to this one, and then divided by 2, you're going to have 1, then here 3. What we're going to have is this one times 3. Now let us calculate using our, if we're going to calculate it live, what you're going to have here is 0, then 12, then 4. So 420 Newton. So the mass, the weight, the weight of the rugby, rugby post is this one. So this is how we can obtain the weight of the rugby post at obtaining the distance of center of gravity from the ground.